All right, we are fresh off that Cubby win. How about them Cubs? All right, so first off, what I want to do is talk about our warm-up. Our warm-up is a radical review, so we learned this in algebra. It says, simplify each expression. Your answer must stay in simplified radical form. No decimals allowed at all. So when we simplify radicals, what you're going to do is you're going to do a factor tree. And when you do a factor tree, you want to get this in prime factorization, the lowest possible numbers you can. So what multiplies to 160? It's 16 and 10. 16 breaks down to 4 and 4. 10 breaks down to 5 and 2. Now here we're going to take out a pair of 4s. I know I always tell you to break it down, but I'm going to make this quick. We're going to take out one pair of 4. There's no pairs for 5 and 2, so those go back inside. Remember, every time you take something out or keep it inside the radical, you multiply it back together. So this answer is going to be 4 root 10. In the second example, we have two radicals being multiplied, and if you remember, you have innies with innies, outies with outies, which means you multiply the outside numbers together and the inside numbers together. You cannot do one of each. You have to stay where it's at. So 3 times 1 is 3, and 6 times 18 is 108. We're going to bring this 3 down to our answer because we have to use that later. We have to break down 108 first, and that breaks down to 3 and 36. And 36 breaks down to 6 and 6, which we can take that out because it's going to, we're going to break it down and everything will come out to multiply to 6. And in this case, we have 1 3 left, so that stays inside. Now you're going to take that 6 you took out originally and multiply it with the 3 from the original problem, so it's going to give you a final answer of 18 square root 3. Square root of 225, if you break it down, totally fine. This one happens to be one of those perfect squares. So you can memorize your perfect squares. I would memorize up to 15 or 16 because then you don't have to rely on your calculator or factor trees. You can just say, oh, 225 is 15. The first thing we're going to talk about today is the Pythagorean theorem. Pythagorean theorem is a formula that reads a squared plus b squared equals c squared. If you think back to our lessons before, we talked about what pieces are of a right triangle. If you remember, the two sides that form that right angle, those are called legs. And the side that is way across, or right across from the right angle, is called the hypotenuse. Remember, A and B are the legs, and C is the hypotenuse. A and B can be interchangeable. It doesn't matter if you put 6 for A or B, but it does matter that hypotenuse always is put in for C. So if we have A squared, we'll call A 6, we'll call B 4, and C is X. So we would say 6 squared plus 4 squared equals X squared. 6 squared is 36, 4 squared is 16, and that equals 52. The inverse of x squared is square root, so you have to break down 52. So if you break down 52, you're going to get 4 and 13. 4 breaks down to 2 and 2. 13 is a prime number, so you cannot break it down anymore. So you have take out a 2, and the 13 stays inside the square root. So our hypotenuse in this example is 2 square root 13. In example 2, our values have changed. So our variable is now one of the legs. Our hypotenuse still across from the right angle. It's now a value. And then this is a leg, and this is a leg. So we're still going to do a squared plus b squared, but our b squared happens to be x, equals c squared. 12 squared is 144, plus x squared equals 15 squared, which is 225. Since the x is one of the legs, we now have to perform one more math operation, and that's either add or subtract that number. And then 225 minus 144 gives you 81. And again, you're going to take the square root, so x equals 9. So in this example, our leg has a measure of 9. Sometimes I'm going to give you examples in words, not so much the image. This is where you have to know what part of the triangle is named what. So sometimes it really does help to sketch out that right triangle. It says if two legs of a right triangle measure 5 and 12, what is the length of the hypotenuse? So knowing that it's asking what is the length of the hypotenuse, that's going to be our variable, which means our other two that form that right angle, those are our legs, so we have 5 and 12. So we have an A, we have a B, and we have a C. So again, we're going to do A squared plus B squared equals C squared. 5 squared is 25, 12 squared is 144, and then you have x squared. 25 plus 144 is 169. And then again, take that square root. 169 is a perfect square, which is 13. So in this example, our hypotenuse is 13. In example 4, I give you the length of the hypotenuse. The length of the hypotenuse is 25, and one leg is 15. So we're looking for that other leg. So again, you're going to do your a squared plus b squared equals c squared. (15 squared is 225. Like I said, you need to know up to 15. 25 squared, that's a big one. I'm going to give it to you. It's 625. Here, again, we have to move that one number to the other side. So you have x squared is equal to 400. If you take the square root, take out your calculator, see if 400 is a perfect square by doing the square root. You're going to find out that it is. It's 20. Some of these answers have been all whole numbers. Some of them have been giving you a simplified radical. The ones that are whole numbers, they can be classified as Pythagorean triples. A Pythagorean triple is a 3 set of non-zero whole numbers. That is the key word, whole numbers, a, b, and c, such that a squared plus b squared equals c squared is true. Some examples of Pythagorean triples are 3, 4, 5, where 5 is the hypotenuse because it is the longest side, 5, 12, 13, 8, 15, 17, 7, 24, 25. You need to memorize these because it's going to make your life a lot easier when it comes to solving Pythagorean theorem. So you can have these examples or multiples of them. So if you look back at the example we just did, 5, 20, and 25, or 15, sorry, 20 and 25 are multiples of this 3, 4, 5. So 3 times 5 is 15, 5 times 4 is 20, this other leg, and 5 times 5 is 25. So they are visible in multiples of these triples, so it does help. So what we're going to do is says, solve the following examples, tell if the side lengths form a Pythagorean triple. So we have to use the Pythagorean theorem. So we have x squared plus 12 squared equals 15 squared. If you have x squared plus 144 equals 225 and you subtract, x squared is going to give you 81. And so x is 9. Is this a Pythagorean triple? Well, yes, it is, because every single side is a whole number, like I said, and they're multiples of the 3, 4, 5 triple. In example 6, sorry, my dog is thirsty. She's nuts. In example 6, here we have a squared plus b squared equals c squared. Here you have 225 plus 81 equals x squared, which gives you 306 equals x squared. 306 is not a perfect square, so if we were to go ahead and simplify, we'd have 18, 17. This is 9 and 2, 3 and 3. So you have a pair of 3's, so that comes out, and then two numbers left over, 2 and 17, so that's going to give you 34. So since that is a simplified radical, no, this is not a triple. Okay? Now, one more thing you can do with the Pythagorean theorem is the Pythagorean inequalities theorem. This is something that you need to know for your quiz and your test. It can tell you if a triangle is right, acute, obtuse by using the Pythagorean theorem. The thing that you do differently is you must put C first. So in these three examples at the bottom, you have to state if it is a triangle first. If it is a triangle, then we have to say what kind of triangle it is. So remember, if you think back, you add two of the sides, and if it's greater than the third, then it's right, or it is a triangle. So 8 plus 11 is greater than 13. And then you try another one. 11 plus 13 is greater than 8. And then you would do 8 plus 13, that's greater than 11. So yes, this is a triangle. But what type of triangle it is it? So we have to do C first. C is always the largest side. So it's the longest side you see, so in this case 13. So we're going to do 13 squared. I'm going to put a box here because we don't know if it's equal to, if it's less than, or if it's greater than. That's what we're trying to find out. And then you take your other two sides and square them, just like Pythagorean theorem, like we have been doing. You have 13 squared, which is 169. Draw a box again. Then you have 64 plus 121. When you add those together, you get 185, and we have to ask ourselves, is 169 equal to, less than, or greater than 185? In this case, it's less than. And if you look up here, it says if it is an acute triangle, then that's less than. So this is an example of an acute triangle. In example 8, we're going to do the same thing. So first check to see if it is a triangle. So 7 plus 12 is greater than that third side of 16. 12 plus 16 is greater than that third side of 7. And lastly, 7 plus 16 is greater than 12. So yes, this one is a triangle. Now we have to again find C. It's that longest side. And then we have to add together the other two sides when they were squared. So 16 squared is 256. 7 squared is 49. 12 squared is 144. 49 plus 144 is 193. So which one is bigger? 256 is greater than 193. So this is an example of an obtuse triangle. Now if you were to simplify both these sides, and you would have both sides be equal, then it would be a right triangle. Look at example 9. Is 5 plus 8, or 5.8 plus 9.3 greater than 15.6? It's not. When you add these together, you get 15.1. So since these two sides added together are not greater than that third side, this is not a triangle. If you have any questions, come on in. You have a quiz coming up, so make sure you are asking them. Good luck on your homework.